Hey everyone, thank you so much for joining in today. So this is a mix of both theory as well as hands-on session. Now, as part of our learning, we'll get to understand how to perform the feature selection when we talk about machine learning models. Okay, so that's how our learning journey will be. So let's get started. Now, as part of our today's agenda, so we'll understand why do we require feature engineering and what is this feature selection. Then we'll understand the importance of feature selection. We'll look into the statistics, like feature selection statistics. We'll look into the feature selection techniques with an hands-on manner. And then we'll also look into the advantages and the disadvantages of this feature selection. So that's how we progress in our learning journey today. Let's start by understanding what is the need for feature selection. Why do we actually require this feature selection? So in order to explain this, let's take up a data set, okay, for the learners, for very beginners. So let's take up a data set. I have the information of name, marks, address, race, religion, and the attendance. Okay, so this is what our data set would look like. Now, these are the various features that we have. Now, if you look at it in this various features, okay, so suppose if I'm predicting the student's performance, if I'm thinking about student's performance, obviously there's no necessity for me to know about their race and religion. So these are the columns which are irrelevant for me. So obviously in such scenarios, we can directly drop those columns. Yes, we can drop those columns and we can work with the data. We can work with the data. So as a result of this, I'll be having lesser number of columns. Since I have lesser number of columns, that's the best thing. I can perform my training in a much more easier way and in a faster way. So that's the requirement of a feature selection. Now, in order to give you some more information, so all the features, the model did not give the good accuracy. Let's say if I use all the features, I'm getting the accuracy at 60%. Now with relevant features and best features, the model actually performs well. Okay. So one reason is since all the features in the model will not give us the good accuracy. With the relevant and best features, the model actually performs well. And this is just some more information. Now, when I say feature selection, it's about I have the complete features that are with me. So when we say feature selection, we have all the set of features. We have all the set of features. Feature selection means selecting the features which is of our interest. Okay, that is what of feature selection. Now at the end of it, so obviously from this set of features, we have selected these final features. Now, what exactly is this feature selection formally? So feature selection means selecting the optimal and the best features for my machine learning model and removing the irrelevant or partially relevant features from the data set. So this is what a feature selection would mean. Okay, so why do we require this? Why do we have to perform this feature selection? Well, obviously, one, it will help us in reducing the curse of dimensionality. Two, it will minimize the cost of computation. So if I have 100 features and if I have two features, obviously the model is going to give me a better accuracy and it will be much better speed if I have just lesser number of features. Obviously, it will minimize the cost of computation and it will help in learning the model, and along with that, it will also help in achieving the good accuracy when we are working with machine learning model, guys. So now that you have seen the importance of feature selection, and generally when we talk about any machine learning and data science in general, so this is a topic where we are using it at the current industry. And if you look at the number of job openings that you have in data science and deep learning technologies, it's enormous and it is growing 30% every year. Now, when you're learning a technology which is in great demand, which is most often or most in demand technology by the industries, it's always recommended that you follow a learning technique, which is a sequential learning technique. Now, when you say sequential, it's a kind of learning technique where you're going to progress in each and every module, which builds upon the previous learning. And when you take the Edureka certification learning journey, every course follows a structured learning approach. If I want to talk about the structured learning at Edureka for this deep learning certification, now during this deep learning certification journey, as part of your first module, you'll get an introduction to deep learning. You'll understand what is deep learning, how to create a neural network, how to work with TensorFlow, and then you'll go ahead and understand how to start coding with TensorFlow in the second module. As part of third module, you learn about convolutional neural network, which is one of the go-to neural network for performing the image classification task. And then you will go ahead and understand about RCNN. These are the models which we use it for performing the object detection. And as part of module 5, you learn about unsupervised learning technique in deep learning, that is Boltzmann machine and autoencoders. And as part of your module 6, you'll also learn about GANs, which are nothing but generative adversarial neural networks. And module 7, it's all about emotion and gender detection using the convolutional neural network and OpenCV. And module 8, it's about working with recurrent neural network and GRUs, which are the sequence learning algorithms. And module 9 and 10, it's about LSTM and using this LSTM and the CNN together to work on an advanced project which is called as auto image captioning using CNN and LSTM. Now here in this scenario, what happens is you're just going to upload an image, and once you upload an image, that image, by looking at it, it's going to generate the captions. Let's say I have an image and the image will say, if I'm driving in a bike, it says person driving a bike. So that's how the advanced the project will be from this deep learning certification course. And as you can clearly see, you are going to cover each and every kind of network architecture that is required for you to start working in the role of a deep learning journey. Okay, so moving on in our agenda, let's look at this feature selection statistics. Now, when I talk about this feature selection statistics, okay, so here, while working with the data, if the data set is a categorical data set, then we can actually make use of a statistical test, that is chi-square test or mutual information. Okay, if I have my numerical input data, but the output data is a categorical in nature, then we'll make use of ANOVA test or Candle's rank coefficient test. So ANOVA is nothing but the analysis of variance. It's about if I have something in my, if there is some special effect, so what is the effect it has on the overall data set? In such scenarios, we'll make use of this ANOVA test. And if I have my categorical with numerical output variable, then we'll make use of ANOVA or Kendall's rank coefficient. And if it is both of them are numerical, then we'll make use of Pearson correlation coefficient and find these important features, guys. So this is how we work with the overall data set. So let's see and let's look at how we can perform the feature selection techniques in a hands-on manner. Now, whenever we are talking about this feature selection techniques, okay, so we have two kinds of method. One, we have supervised feature selection technique, and another method is called as unsupervised feature selection technique. Under this supervised selection technique, we've got filtering method, we've got wrapper method, we've got embedded methods. So these are the three main feature selection, supervised feature selection techniques that we have. Now, here, when we talk about this feature selection technique, so normally what we do is from the collection of all features, I'm going to select the required features which are best as per my given problem. And then we are going to apply it on a machine learning algorithm. And then we are going to measure the performance of our machine learning algorithm. So this is how we actually perform the feature selection technique. This is the process that is involved when it comes to feature selection technique. Now, under this supervised feature selection technique, the one technique that we have seen is called as filter method technique. Now, under this filter method technique, so we have the information gain technique. So this information gain helps us in determining the reduction in entropy. Okay, so entropy is a loss function that I'll be using whenever I'm performing the task of classification. So this information gain makes use of entropy. And under this filtering method, we can make use of information gain, which determines reduction in entropy. We have chi-square test, which determines the relationship between the categorical variables. We have Fisher score, which returns the rank of the feature in a descending order. And we have the missing value ratio, which evaluates the feature set against the certain threshold value. So this is about my feature method, that is the filter method technique. Moving on, the next method that we have is called as a wrapper method, guys. Now, under this wrapper method, okay, so what happens is the same thing. So I'll select a feature subset and then apply it on a learning algorithm. Now, under this wrapper method, okay, under this wrapper method, what we do is we are going to begin with the empty set of features. Okay, so we are going to begin with empty set of features. And then with each iteration, we keep on adding the features and then we are going to perform the evaluation. So what we normally do is here, this technique that is being followed in the scenario of this wrapper technique is it actually follows a greedy search approach. So it follows this greedy search approach by evaluating all the possible combination of the features against my evaluation criteria. So this evaluation criteria is simply the performance measure which depends on the type of problem. For example, if I'm working with the regression, it will be it can be p-value or a r-squared value, adjusted r-squared value, and so on. And similarly, if I'm working for the task of classification, it can be accuracy, precision, recall, F1 score, and so on. Finally, it's going to select the combination of feature which gives the optimal results for the specified machine learning algorithm. Now, under this wrapper method, so we have this technique of forward selection, backward selection, and there's one more technique that's called as exhaustive feature selection. Okay, exhaustive and recursive feature elimination. So like here, when we talk about this forward selection, it actually begins with the empty set of features. With each iteration, it keeps on adding the values and evaluate it. And in the scenario of this backward elimination, it begins with all the features with each iteration and removes the least significant feature. And we'll perform the evaluation on the basis of brute force method in the scenario of exhaustive feature selection. And under the recursive features elimination, it is recursive greedy optimization approach. Now let's do one thing in order to help you understand this wrapper method. Okay, since it's more of an abstract concept, let's take up the hands-on approach. I'll create a new notebook and we'll work in a hands-on manner. All right, now let's get started and let's start working with the data. Now, in order to show this example, I'm going to load a data set that is called as Boston house prices. Okay, so we'll make use of the Boston house prices data set. For that, I'll say from sklearn.datasets import load underscore Boston. Okay, and then I'll say Boston is equal to load underscore Boston. So this is going to load the data set. And once the data set has been loaded, okay, so once the data set has been loaded, let's get our data and the features. I'm going to say import pandas as pd, okay, and I'll create a data frame. So I'll say pos is equal to pd dot data frame. Okay, I'll specify my Boston dot data, comma, columns is equal to Boston dot feature underscore names. Okay, and if I display my Boston, this is how my overall Boston data set would look like. We also have a target column. I'll say boss price is equal to Boston dot target. Okay, so if I display the first few entries of my data frame, now I have added the target column as well. That is the price column. Okay, so we have now prepared the data set. Okay, I'll do one thing. I'll also separate my X and Y. Okay, So I'll remove this X. Okay, we have mentioned in place is equal to true. Okay, next I'll specify my last column for the Y. Okay, I have separated my X and Y. Now let's start with the forward selection technique. So in the forward selection, we'll just start with the null model, and then we are going to start fitting the model with each individual features one at a time. And then we are going to select the feature with the minimum p-value. Now we'll fit the model with two features by trying the combination of the previously selected feature with all the other remaining features. Again, we'll select the feature with the minimum p-value, and then we'll fit the model. Okay, we'll fit the model with three features by trying the combinations. Okay, so that's how we are going to do. So in order, like if I want to specify it in few words, first I'm going to select a significant value. Normally we'll specify the significant level as 0.05, and then we are going to find all the possible simple regression model by considering one feature at a time, and then we are going to fit all the possibles with one extra feature, and we repeat this process. In order to implement this, I'm going to create a function that would look like this. Okay, so this is how the overall. Okay, I have removed it. So this is a function which will take care of forward selection. So here, this is going to accept my data and the target variable, and it is also going to consider the significance level. So I have set the default significance level as 0.05. And here, this is going to return the significant features on the basis of p-values through the forward selection. Okay, so that is what it is going to do right now. Now, so this is going to take care of the working. Now let me just give this data. Okay, so what I'll do is I'll call this function forward underscore selection, and I'll call this X and Y. So if I execute this, okay, currently it says stats models OLS. So import stat models dot regression dot linear underscore model. Okay, let's see. I think this should work now. So I had to import the stats model dot API as SM. Now once it's done, so it has been resolved, and here we have the output, and these are the output that we have as a result of performing this forward selection operation. Okay, so this is how it has returned the final list of significant features on the basis of p-values. Okay, now what we can do right now is once we have the output of these features, okay, once we have the output from forward selection, so we can implement the forward selection using the built-in functions that we have in Python. So in order to implement this forward selection, we have a library that is called as MLExtend. So this ML extend library contains the built-in implementation for most of the wrapper methods, which are based on feature selection. And here, in order to do this, first I'll import my ML extend library. I'll say from ML extend dot feature underscore selection, I'll import sequential feature selector. Okay, I'll import this sequential feature selector, and then I'll write as from sklearn dot linear underscore model will import linear regression. Okay, now what I'm going to do right now is, okay, no module sklearn. It looks like it is trying to find this package. Due to the latest update, the team of ML extend has not fixed it, and that is the reason that we are getting this. Okay, now I want you to go through this link and just try around. I think there is some error with this backward selection. So we are getting an error while performing the fit, but overall this is quite working fine and we are able to implement this forward selection as well as this backward selection. Okay, so this is how you can do this activity, guys. So what we have done right now here is, so here we have performed the sequence, we have made use of sequential feature selector, and we have implemented the forward selection and backward elimination technique. So we have imported the same and we have worked with the help of ML_extend library to apply this wrapper method techniques. Okay. And then under this, like if I just want to move on and explain the other methods that we have over here in filter method techniques, we have embedded methods. Under this embedded methods, yes, we have in this embedded method, we have the regularization techniques like L1, L2, and elastic net. And along with that, we can also make use of random forest or tree-based methods for performing the feature selection. So you have just seen about how to perform this feature selection, and we have also performed in a hands-on manner for the feature selection with forward technique and the backward technique. Now, if I want to name some of the advantages of this feature selection, obviously, so here, so when it comes to filter method, it has better computational complexity and it is independent of my classifier and it is fast and scalable. When it comes to wrapper method, it minimizes my computational cost. Model is feature dependent and interacts with the classifier. Okay. Now coming to the disadvantages. So coming to the disadvantages, when it comes to my filter method, it ignores the interaction with classifier, it ignores the feature dependencies, and there are some vagueness in the filter method. Now coming over here for the wrapper method. So this is computationally intensive. We have a risk of overfitting and it has a very low discriminative power. Okay, so these are some of the advantages and the disadvantages of filter method and the wrapper method, guys. Okay, so just want to let you know again, when we talk about feature selection, see, feature selection is nothing but selecting the features from the overall data set. Okay, so here we are going to select the most significant and relevant features from the vast set of features in a given data set. And in order to select the relevant features, we make use of these various feature selection methods. We've got filter, wrapper, and embedded methods. So with this, we come to the end of today's session, guys, where we have seen the implementation and we have also learned about the various techniques of feature selection. Thanks a lot for joining in, and I look forward to seeing you in the next learning sessions. So take care.